After an insightful first session from Kishore Naran, we will start with our second session for the day by Divya Madana. She'll be speaking on DevOps best practices in the Agile world. So before starting, let me thank our founding sponsor, Innovation Roots. Innovation Roots is a leading consulting, training, and service provider, helping organizations to believe business agility and beyond. It is one of the leaders and pioneers of niche publishing services and well known for content collaboration with global thought leaders, authors, and creators. So, for more information about Innovation Roots, request you to visit www.innovationroots.com. So, do's and don'ts for the session. Please join the session 5 minutes early. Use high quality speakers and headphones. Please keep yourself muted and video disabled as this may cause disturbance. Questions will be taken to chat box. Request you to post it in the chat box. Our facilitator or moderator will read for you. Post session, please fill the feedback form. We appreciate your cooperation. So before starting the session, let's welcome Divya Madana. Divya Madana is Director Software Engineering. She has 19 plus years of experience in diverse experience in IT where she has worked in different domains like retail and PFSI. With this, I would like to welcome Divya. Over to you, Divya.
Thank you, Prashant. Thank you so much. I'm very happy to be part of the community, and I would like to share whatever knowledge I have gained and the experience that I have captured during my 19-20 years of journey in the industry. I'm primarily from the automation and the quality engineering background, and DevOps is a topic close to my heart. I have been the leader in driving the DevOps adoption program during my professional years. So let's begin. The session for today. So we all have been, long enough in the IT industry to understand that the software development lifecycle has come a long way from operating in the sequential and siloed waterfall model to being agile and collaborative. To be able to cut down the time to market and optimize costs, the evolution of the waterfall software development processes was necessary. And this gave birth to the new ways of working with the extensive adoption of Agile and DevOps. So relevant to this, the topic of today's session is DevOps, best practices in the Agile world, which is in itself is a vast subject. And for this session of 50 minutes today, I have endeavored to put together the content covering the various diverse aspects of DevOps and with a certain level of depth that I thought would be optimum for such a session. So in next 50 minutes, I'm going to touch upon these aspects of the subject, which I have observed, implemented, learned during working in various organizations, and it includes the research of my own. In my references slide, I'm also going to share 3 wonderful books that are very helpful, to understand the concept in depth. And I have also included the concepts and the frameworks and, the content from these 3 books as well. So you will get to know that as well. I would specifically like to call out a couple of things, which is that this is not a DevOps training session. I will give an overview of DevOps practices and its associated challenges with some examples and perspectives from the industry. Overcoming these challenges would automatically become the best practices. So you can think it that way. And also, I am not promoting any of the particular tools that I'm going to talk about today or mention about them during the session. And also, the third thing is that I'm okay if anyone from the audience would want to reach out to me outside of this session to have a constructive discussion on this subject. Please feel free to DM me on LinkedIn and we can learn from each other. All right. Having said that, let's set the agenda for today. I'm going to talk for 5 to 7 minutes about introducing and bringing a lot of refresher to the table today, about the DevOps and Agile concepts and how they are interrelated. And then we are going to touch upon 5 or 6 best practices for DevOps in the Agile world, which includes cultural transformation, governance through metrics, automation, continuous integration and continuous delivery, centralized Agile and DevOps philosophies, and continuous deployment. Also, I'm going to touch upon briefly during the end of the session about the myths that many people have in their minds about DevOps. And later, we will open the forum for quick Q&A. Okay. So let's begin with a refresher. We all know the Agile methodology concepts. Okay, so the Agile methodology is a way of working and managing a project by breaking it up into several phases. It involves constant collaboration with stakeholders and continuous improvement at every stage. Once the work begins, the team cycles through a process of prioritizing, implementing, and evaluating the features. Is my screen visible? Prashant, can you
Yes,
confirm?
Divya. Yes, yes, yes,
Slides
it's
are
visible.
visible, right?
And your voice is also very clear.
Okay, all right. So the team cycles through the process of prioritizing, implementing, and evaluating the features that will bring value to the customer. The 3 key underlying principles of Agile methodology are transparency, inspection, adaptation. And these are called empirical principles or empiricism in Agile. Empiricism forms the basis of Agile, which means working in a fact-based, experience-based, and evidence-based manner. Scrum implements an empirical process where progress is based on observations of reality and not fictitious plans. It places great emphasis on mindset and cultural shift to achieve business and organizational agility. The ideal Agile team could be 5 to 6 people, primarily categorized into 2 roles, Scrum and development. Scrum team consists of product owner and Scrum master, while the development or the engineering team comprises of developers and quality engineers. Let's take a real brief look at what are these roles all about. A product owner, it's often an executive or key stakeholder. The product owner has a vision for the product and a sense of how it will fit into the company's long-term goals. This person will need to direct communication efforts, alerting the team to major developments and stepping in to course correct and implement high-level changes as necessary. And you can also understand the product owner being the voice of the customer. This role listens to customer, aligns the priorities backlog, which creates value to the customer, and that's the whole basis of Agile. The second role is the Scrum Master. They are guardians of process, givers of feedback, and mentors to junior team members. They oversee day-to-day functions, maintain the Scrum board, check in with team members, and makes sure that the tasks are being completed on target. Scrum Master facilitates, coaches, and guides team to follow practices and resolves impediments. The development or engineering team roles goes by this. Engineering team members are the developers or quality engineers or creators, makers. So front end, back end engineers, quality engineers. This is what the development of the engineering team comprises of, and they have varied roles and skills, but all are responsible for getting work done on time with excellent quality. Now, in any IT organization, to deliver the product to the end user or customer, we need IT operations and security teams with 2 major mandates for these teams. One, respond to the rapidly changing competitive landscape. Second, provide stable, reliable, and secure service to the customer, which is very important. So now, why did we need DevOps? So now let's understand what has been the reason for the chronic conflict between development and ops teams. So here comes the interesting part. Development role takes the responsibility to respond to the changes in the market by deploying features and changes to the production as quickly as possible. That's what their KRA is. While the IT operation role takes responsibility for providing customers with IT service that is stable, reliable, and secure, which makes it difficult for even impossible for anyone to introduce production changes and jeopardize production. So configured this way, development and IT operations have diametrically opposite goals and incentives. And this is the reason for the chronic conflict that has been going on for decades. Now let's imagine a collaborative world where product owners, development, QE, IT operations, InfoSec, they all work together towards the common goal to deliver the planned work into production fast, ensuring world-class stability, reliability, availability, and security of the product. Now, in this collaborative world, cross-functional teams rigorously test their hypothesis of which feature will most delight the users and advance the organizational goals further. They care for not just implementing the user features, but also ensuring that their work flows smoothly and frequently through the entire value stream without causing chaos and disruption to IT operations or any internal or external customer. How it is done? By adding the expertise of quality engineers, IT operations, and InfoSec into the delivery teams and automated self-service tools and platforms. Now, teams can use that expertise in their daily work without being dependent on other teams. This collaborative way of working enables organizations to create a safe system of work where small teams can quickly and independently develop, test, and deploy code quickly, safely, securely, and reliably to the customers, thus enabling the organizations to maximize the developer productivity, organizational learning, creating high level of employee satisfaction, and win in the marketplace. This enablement of cohesive and collaborative way of working between the development and IT operations is DevOps. So now we understand the basic concept of Agile and DevOps, how they are interrelated, why are they needed to be implemented together, and what are the expected outcomes of both of these philosophies. Here, I would also like to bring attention of the audience to one more important point, that Agile is a precursor to DevOps, and both go hand in hand to make an organization successful. All right, let's move on now to understand the topmost few best practices of DevOps that I've experienced and observed as being implemented during my professional journey. I'll talk more in terms of the challenges, of course, and the opposite of it will become best practice, like I said earlier as well. And also, given the progress in the DevOps world that has happened, I'll start with the ones which I feel need to be dealt with higher priority. Over the past few years, I have observed that the challenges in DevOps adoption and enhancing maturity are less technical but more cultural. So here we start with our first best practice, which is cultural transformation. Okay, so in the cultural transformation, this is what we are going to talk about. So many may think that the most difficult part of DevOps implementation is technology. On the contrary, cultural transformation is the toughest to accomplish. Properly embracing DevOps entails a cultural change where teams have new structures, new management principles, and adopt certain technology tools, understand each other's roles, and come out of silos and work collaboratively together towards a defined purpose and shared goal. In my experience, I have observed challenges such as lack of culture of experimentation at organization, because it does not allow you to do a lot of proof of concepts or try the technologies. Fear of failure, that if I fail, then what will happen? If I fail to implement a tool that I have taken in the DevOps stage of a pipeline, then what will happen? Risk averse culture of the organization is detrimental for such an experimentation. Lack of vision, lack of vision sharing by the leadership team, which doesn't percolate down to the bottom of the entire team. And hence the employees are not able to connect with the vision, and failure to follow the direction of the transformation that the organization is trying to do through DevOps. Let's now see the major part of building DevOps culture. There are three strong aspects on which the structure of DevOps team typically depends upon. One is the number and nature of products an organization works on. Second, the technical leadership and tech stack along with the number of tools. For example, firmware or legacy apps might be difficult to move to DevOps if development and operations team have the capability to align to the processes or not. Now let me share in my experience, there have been 2 or 3 ways of putting together the DevOps structure in place. Number one that I have seen is the formation of the centralized DevOps transformation office or model. So in this model, the autonomy and power to work with the product teams and engagements, or you can call it a capability, function, division, whatever you want to call it, to assess and improve the DevOps maturity of the product teams. Now, this structure can have clear OKRs tracked on quarterly basis. To empower this structure, the same OKRs are tied to the KPIs of the product teams. I hope everyone understands the meaning of OKRs. It's objectives and key results. And this, now every company is using OKRs instead of calling it goals. Now, this DevOps team structure generally consists of a DevOps coach, who generally is a highly experienced DevOps practitioner or leader, and DevOps evangelist, who drives the DevOps adoption with the Agile product teams. An evaluation of existing skill competency assessment on the tool stack, the tool stack that you're using already, that assessment happens. Technology, it can be carried out along with the DevOps maturity assessment. For example, skateboard, cycle, scooter, car, or you can also call it crawl, walk, run, fly. So these are all the maturity levels defined on the basis of the maturity definitions. The teams can identify their current maturity and target to reach another level of maturity within a given timeline. Now, of course, a maturity assessment framework is needed to define and identify the DevOps implementation, and the maturity enhancement can be tracked at a suitable frequency. Now, also there are certain activities that happen in this model, for example, creation of DevOps playbook, guiding principles, centralized dashboard for live tracking of the metrics, centralized tool stack, etc. These are some of the best practices followed in this operating model. A quick call out, that for large organizations where the teams are distributed geographically, it can cause a lot of challenges to carry out this kind of adoption program. So it needs to be very carefully strategized and planned to overcome, this kind of challenges for the enterprise level implementation. So this is one model, and where an internal technical person is identified as a SPOC per team to drive the DevOps mandate. The other model, which is more successful, is embedding the DevOps engineer inside each product team, while the DevOps horizontal can provide the governance. All right, now let's move on to another aspect, which is site reliability engineering. Site reliability engineering, or generally known as SRE, is a specific implementation of DevOps. An SRE team is responsible for ensuring the availability, latency, performance, efficiency, change management, monitoring, emergency response, and capacity planning. This team structure was popularized by Google, and this is where a development team hands off a product to the SRE team, who actually runs the software. In this model, development team provides logs and other artifacts to the SRE team to prove their software meets a sufficient standard for support from the SRE team. There are certain types of recommendations that Google has shared to form the SRE team structure, like kitchen sink, which also means everything SRE. Infrastructure, tools only team, where a tools only SRE team tends to focus on building the software to help their developer counterparts measure, maintain, and improve the system reliability or any other aspect of the SRE work. There is another way of putting together the SRE team is product or application. The SRE team works to improve reliability of a critical application or business area in this particular model. And the one that you can also see on the screen is the embedded one, where the SRE team members are embedded inside the product teams. And the horizontal capability provides the SRE governance to these chapters. So in a nutshell, there are a lot of ways that a team can be structured depending upon the organizational structure, complexity, culture, technology, and existing processes, and of course, the vision of the organization for digital transformation. Now let me share a very interesting concept, and this is newest on the blog, which has also been described. So there's a book that has been written, by the way, the Team Topologies by Matthew Skelton and Manuel Paes. And there are very interesting aspects of building efficient and effective org design to push DevOps in this book, and I'm going to share at least in 3-4 minutes what is the crux of the matter that they're trying to convey here. And I've seen this model of streamlined teams, I'm going to talk about it shortly, getting implemented in large organizations. So what they've suggested, a team approach is, that the team first approach, which means cohesive set of people working together on same set of business problem, which means by understanding the human systems first and then designing the software architecture instead of the other way around. And that can be identified by identifying the cognitive load that the team has. Now here the book provides very insightful ways the organizations can build DevOps into their company. And let's also, understand what does this cognitive load actually means. So it means the total amount of mental effort being used in the team's working memory. And it can be categorized into 3 cognitive loads, basis the skills, mechanism, and domain respectively. One is intrinsic, which is the fundamental way of working in softwares. For example, if you have to figure out how your classes are defined in Java. Second is extraneous, which means distractions, such as figuring out how does the configurations or settings of the software work. For example, how do I deploy this application? And third is germane, understanding the part of business problem we are trying to solve, such as how does the bank transfer work in the application you are testing or developing? How does the order placement work in an e-commerce portal? So what they have suggested is that the best way of implementing the cognitive load philosophy is by maximizing focus on germane cognitive load, dealing with the intrinsic load, and minimizing the extraneous load, because extraneous load can be minimized by documentation, training, upskilling, and it's easily doable. All right. So the point is, we should limit the size of software services and products to the cognitive load that the team can handle. For example, limiting the team size to 9, maximum to 15, assigning full ownership of service to one team to build and operate. Okay, in the same under the same topic, what there is a detailed way also given that how these teams can be set up, and it's very interesting to see, and I have seen this getting implemented in large organizations. In 2 minutes I will cover this. So the team topologies of 4 different kinds are defined. Number 1 is stream aligned. Teams that align to part of the value stream of the business with end-to-end responsibility of building, testing, deploying, running, supporting that slice of the business domain. And it is also described in the Agile principle number 10, if you would like to see. Organizing around value. So the value stream concept is a critical underpinning of lean thinking and fundamental to the scaled agile framework. We call it as a SAFe, S-A-F-E. And in the scaled agile framework also, there are 2 types of value streams that are described: operational value stream and development value stream. The operational value stream are the sequence of activities needed to deliver a product or service to a customer. Examples include manufacturing a product, fulfilling an order, admitting and treating a medical patient, providing a loan, or delivering a professional service. And development value streams contains the steps and the people who develop the business solutions used by the operational value streams we just discussed. Now, if the value stream model is followed, then there are 3 types of teams that becomes the supporting services to share the cognitive load of this main model. Enabling teams, complicated subsystem, and platform teams. Now, what does the enabling team do? To upskill the stream aligned teams, detect if there are any gaps in the platforms on which stream aligned teams are expected to deliver things, or to help a stream aligned team to overcome the obstacles. It also helps to detect the capability gap. Where is the upskilling needed? Which tools and technology should be needed by the stream aligned team, and things like that. An enabling team composed of specialists in each technical domain, and it helps to bridge this capability gap. These teams focus on research and experimentation to make informed suggestions about tooling, frameworks, and ecosystem choices that affect the tool stack that the stream aligned team is using. Now, what does the complicated subsystem mean here? The complicated subsystem team is responsible for building and maintaining a part of the system that depends on specific skills and knowledge. Most team members must be specialists in a particular area of knowledge to understand and make changes to the subsystem where significant mathematics calculation, technical expertise is needed. So there are some examples you can understand from writing the business logic of a complicated subsystem to offload the stream aligned team from the cognitive load. For example, in financial services, actuaries and underwriting team, or in payment solutions case, billing service. These are some of the examples where the complicated subsystem team is implemented. Now, the fourth type of the team is the platform team, a grouping of other team types that provide a compelling internal product to accelerate delivery by the stream aligned teams. So all of these 3 are the supporting services for the stream aligned team only. Platform teams enable stream aligned teams to deliver work with substantial autonomy, while the stream aligned team maintains full ownership of building, running, and fixing an application in production. And as you can see on the screen, and it's very well described in the book, by the way, if you get a chance, you should read that book. The mode of collaboration, communication, and interactions, how the facilitation, where the collaboration, how leveraging a team as a service, all of these interaction models are described in detail. And this all is done to minimize the cognitive load of the interoperability of these 4 team topologies. All right, now let's move on to the governance through metrics. So in this section, this is what I'm going to speak primarily about. I'm not going to deep dive too much, but I will be describing at least the 4 golden metrics and also some of the newer metrics that are coming into picture shortly. So we know that closely governing the applications to continuously optimize the performance and keeping the feedback loop quick is one of the best practices that organizations follow. Now, implementing a reporting mechanism through dashboards with the purposeful capturing of the appropriate metrics, providing holistic and real-time insights is critical to the dashboard through different graphs, logs, and metrics, because otherwise, how would the stakeholders know if they are not able to interpret the data, or if the data is not available on dashboards live? So it becomes an operational challenge in the organizations to all the time capture the data on the slides and keep on presenting in normal meetings. It doesn't give a holistic picture to the key decision makers. So it's very important that the governance through metrics is done the right way. So the main goals of DevOps adoption are to achieve velocity, quality, performance, stability, security, adoption, and maturity of DevOps practices. And hence the golden metrics also belong to the same category. So the table that you see on the left side of the screen captures a comprehensive list of metrics in each of these categories I just discussed. I'll not be able to go into the details of these, but on the right side, you can see some of the most recommended metrics by DevOps Research and Assessment Center, which is DORA. And it is a pioneer organization working towards helping organizations in achieving their DevOps goals. And also, there's a very good book written by Nicole, Jen, and Jez. It's called Accelerate. So these are the four main metrics that most organizations track, and I'll quickly go over the definitions of the four metrics that you see on the right side of your screen. Lead time for changes. What does this mean? So one of the critical DevOps metrics is to track its lead time for changes. Lead time for change is the length of time between when a code change is committed to the trunk branch and when it is in a deployable state. So that delta of the time. The second one is the change failure rate. The change failure rate is the percentage of code changes that require hot fixes or other remediation after production. This does not measure failures caught by testing and fixed before code is deployed. The third is deployment frequency. Understanding the frequency of how often new code is deployed into production is critical to understanding DevOps success. Many practitioners use this term delivery to mean code changes that are released into the pre-production staging environment, and reserve the deployment word to refer to the code changes that are released into production. MTTR, mean time to recovery. It measures how long it takes to recover from a partial service interruption or a total failure of the system. This is an important metric to track regardless of whether the interruption is the result of a recent deployment or an isolated system failure, so that the root cause analysis can be done appropriately. So this is what I was talking about. As you can see, the bottom right side of your screen, these are some of the metrics specified by DORA, and some of the stream-aligned teams who are implementing this operating model, which I was discussing in the cultural transformation, they are now adopting these metrics. And you know why these metrics are more required now? Because if you see, rest of the four golden metrics are all again technical. But because DevOps is not only about technical implementation, it is all about the mindset and the cultural shift. So understanding how the culture is adapting and adopting this mind shift is also important. Now, how do we measure it? So these are some of the metrics that the companies are tracking, which is balanced team, which means that how much diverse set of skills and perspectives does your team have? Full-time owner. A full-time owner ensures that the nuclear team and cross-functional participants know who to ask questions to and how to make decisions related to projects owned by the team, so that the team is not directionless and they know whom to go to. Shared understanding. If there is a shared understanding of the requirements along with the definition of values and metrics, then that defines the success. A focus on value and metrics, whether the team is understanding the focus and the value of metrics, because if the in metrics, in the challenges, I will also discuss this point. I will hold it then. Proof of concept and the managed dependencies to maintain velocity. All right, now let's see some of the challenges that the companies face. And these are some real-time challenges that I myself have faced. And if we are able to eliminate these through proper mindset changes, then really DevOps adoption and implementation becomes successful. So now we've spoken about the golden matrix. We are talking about having all kinds of metrics. But now imagine if the data collection to calculate these metrics is wrong. I mean, we've collected the data incorrectly because we did not understand, what data was need to be captured, or there is a complete absence of data, and I do not have that data to be able to, capture this metric. Then calculation of the actual metric, hence jeopardizing the measure of success tracking. And what is disastrous? The disastrous is part is that the decisions are taken on the basis of these metrics. I'll take a small example here. That if someone in my team says that I have implemented 85% of test automation. Now, first of all, what is the mathematical calculation? What is the numerator? What is the denominator that has been taken to calculate this 85%? How have you reached that stage? And also, how much is the automation script execution happening? Right? Because if you have automated 85 scripts out of 100, fair enough, okay, great. But how many are you executing when the new build is arriving? So it's a wrong metric, right? Because it is painting a different picture. When the build is arriving, the scripts are not working, they are only working 20%, and you are claiming that your automation is working 85%. Now, during estimation of the project, the estimation has been done basis that only 15% manual testing will be required and 85% will be done through test automation. While on the contrary, in reality, only 20% test automation will happen through scripts, while the 80% will still have to be done manually. So this is what I was referring to. Secondly, in the value stream, what happens sometimes is that not every team is upskilled to the agile way of working. So if everyone is not adapted, every small component of the team is not adapted to agile way of working, and some are still working in the waterfall model, then you will still not have the metrics to collect and reach a conclusion. Third aspect is the cultural aspect, which is the human insecurity, resistance to change, fear of becoming irrelevant, losing job, failing to upskill, people dynamics, etc., leading to failure of correct metrics collection. There's one more aspect, which is if the software we are working on, it just doesn't fit in our heads, or if we just don't understand the software well, it is difficult to capture and improve the metric, because this works against the organizational agility. And if the software is too big and complicated, and risk of failures in production will be higher. And that is the exact reason why moving from monolithic to microservices based architecture can provide a direction, and most organizations are doing that as part of their digital transformation agendas. Okay, all right. So now let's move on to automation. Automating the manual activities in the application development pipeline is a key contributor to implement DevOps. I'm sure a lot of people from who have joined today's session would know that, and I don't need to talk about it in that depth. So adapting to shift left testing practices and automating testing activities is an enticing and objective choice. The test automation allows teams to spot the bugs early and faster in the game, and at the same time reduce the regression cycle time exponentially. Understanding your application automation requirements and identifying the right tool stack to automate is an important step. Choosing the right set of test cases for automation is equally critical. Upskilling the team to develop the suitable automation framework needs to be proactively taken care of. Now let's see how the evolution of testing has happened. The evolution of testing practices has happened for good reasons, from manual testing to AI augmented testing, from waterfall to value stream model, which has significantly improved the test efficacy and has cut down the delivery cycle time. AI augmented software testing tools support different approaches to accelerate the testing process. And in my opinion, there is no one tool that can be the panacea of all the test automation needs, but the selection of the right combination of tools that works. And also, that is the most challenging part. Additionally, the hiring market is quite highly competitive for experienced quality engineers, and we've seen that the situation that is persisting in the Indian industry today. The use of AI can dramatically increase the efficacy rate of test automation tools, reducing the need for humans to identify critical issues via traditional testing. So there are a lot of tools in the market that are AI augmented. Again, I'm not promoting any tool, but I'm just talking about the tools that are being widely used. So Tosca from Tricentis, Testim, Apply Tools, Testcraft, Functionize, and just to share my knowledge with you that these so what does Gartner do? Gartner does some research and it also recommends on the various quadrants that the report that it publishes. So this year it has published a tool called Evo Automation. This is just for your knowledge and information. This is also an AI augmented tool. All right, so intentionally did not talk about Selenium BDD and other tools because I'm sure everyone who has joined this session, I'm 100% sure they would know what is Selenium BDD, and I really do not want to dive deeper into that. Instead, let me talk about some of the practical challenges that happens in automation, and the organizations overlook these challenges, and it is difficult to achieve the desired outcome and ROI because of this overlooking. Okay, so let me, yeah. So first is not fixing the processes before automation. So first, we need to understand that automation is all about taking up the manual processes and placing technology on top of them so they are inherently repeatable. That's the basic definition. Now, if your processes are bad or flawed, then you are just making bad processes happen faster by automating them, right? So your first effort should be focused on what process occur during development. Once they are vetted and logged down, it's just a matter of backing the appropriate automation tools into these processes. However, not all processes can or should be automated. Choosing the application for automation is one of the best practice that most organizations ignore. Second is overdoing automation. Overdoing automation. Let me take an example of a retail organization. A retail organization tried to automate the entire life cycle to make it possible for developers to build, test, integrate, and deploy any code at any time with the vision to change applications at the speed of need for the business. But the reality was that new versions of the application code were released to the cloud platform twice a day or more. So the frequency was higher. Now, as a result, the users became frustrated with the number of times the user interface changed, and there was changes in the database which kept on adding or deleting their data. Now, moreover, the automated testing was not completely holistic, and some quality issues emerged that could have been easily caught by the humans. So the result was that the retail organization removed some of the DevOps automated tools from the pipeline. They also limited the types of changes the developers could place and make, and so that there is more rigor around reviews, deployments, and testing. So this is what I meant by overdoing automation. I would also like to just mention a tool. It's called Test Pyramid. If you want, you can just try it out. It explains how to plan automation in the most optimal way. The testing pyramid is a concept that groups the software test into three different categories. So I'm not diving deeper into this subject, but you can take a look at that. All right, and it's now very interesting. So we talk about BDD all the time, and we know how to write given, when, then style and Gherkin scripts. So, what I've seen is, there's this classic example where in an agile team, the business analysts don't write the user stories in BDD. Neither do the developers use BDD, but the test automation engineers, they've developed their framework in automation in BDD style. So, the fun part is that the entire purpose of inventing BDD was to bridge the gap between the requirements that the business analysts wrote after understanding from business, and developers develop the same, and testers use those stories as well. That was the entire idea of inventing BDD. Now the entire essence of BDD gets defeated the moment business analyst says that I don't know what is BDD. I am writing in my natural language, in my natural English language, but I'm not using given, when, then style. But on the other hand, test automation teams have fully adopted 100% test automation is running in BDD. So these are some of the hidden aspects that are being overlooked and ignored. That is the reason I wanted to bring into this content. There's one more thing which definitely I have seen. So not allocating sufficient budget for automation, expecting the existing team to adopt and increase automation without adding bandwidth to the team, or allocating sufficient budget for procurement of automation tooling licenses. Another thing is unrealistic expectations from automation, failing to understand the limitations of the compatibility of legacy systems and automation tools. I'm sure you would have seen, you would have faced so many such challenges, for example, automating the mainframes. So while tools providers may sell automation products that promise to make you the next Facebook or Netflix or Spotify for that matter, the reality is that your organization is not the Facebook or Netflix. If you try to replicate their automation solutions, it is not going to solve your purpose, because the dynamics, tool stack, complexity, processes of your organization are your own. So the investment you have made in DevOps and automation will just blow up, and not because you're not automating enough, because you have attempted to automate too much. Also, there are real challenges in automating the legacy system, which we need to accept and plan to overcome. All right. Now let's move on quickly to the continuous integration and continuous delivery best practices. I am going to give you a brief overview of all the tools that are being used, not all, because let me show you the tool stack. So everyone would have seen this infinity diagram, and there is a plethora of DevOps tools.
Sorry
Is
to
someone
interrupt.
saying something? Sure.
Prashant here. So
Yes, Prashant.
we have overshooted the time. We will take a couple of questions, so you can just cover this slide immediately. Okay.
Okay.
You can just.
Okay. All right. Or shall I just in 5 minutes? Shall I just do this slide? There are some
Please.
interesting things. I'll not go over I'll not go over every tool. Let me just
Yeah.
bucketize it. Okay. All right. So okay, so in the interest of time, I'm not going deeper into, and definitely we can connect later after this session. So please feel free. I'll be very happy to learn from you as well and share my knowledge with you. So in the DevOps CI/CD, in the DevOps entire pipeline, not just CI/CD, because there are other aspects which I wanted to talk, and let me just bucketize them. So from the tooling standpoint, what are the major tools that are being used widely? Because when you see this infinity diagram, I'm sure you will get confused which one to use. So the version control tool, GitLab, GitHub, Bitbucket, these are the widely used. For build tool, Maven is a very widely used tool. For continuous integration, Jenkins is used widely. For configuration management, Chef, Puppet, Ansible, these are the tools which are used widely, depending, and it absolutely depends upon the need of the software, and obviously the compatibility. For container platforms, Docker and Kubernetes, these are the two widely used. For cloud computing and storage, AWS and Azure. For monitoring, alerting, and incident reporting, the most widely used ones are AppDynamics, Prometheus, Kafka, Grafana for dashboarding, Splunk Cloud. So these are the most widely used ones. And definitely, I do not want to go into the technical best practices of implementing these tools. I'm sure there would be so many DevOps engineers here, they know following consistent naming conventions and comments for the branches, following a practice of developing on the root branch, code review practices, setting up 1, 2, or 3 as many required automated quality gates. Um, and for Docker and Kubernetes, auditing your logs regularly, or emitting the Kubernetes performance matrix in a compatible format of Prometheus as an example. On the same slide, you can see a practical implementation and a real world example showing the CI/CD stages along with the tool stack in the second row. So what I've observed is that depicting the CI and CD stages this way, it helps devising your maturity framework, because for each of these stages, you can actually assess the maturity of adoption of DevOps this way, because the infinity diagram is really confusing, to be very honest with you. All right, I'll very quickly just share 4 challenges and the things that are being overlooked by the organizations in just 1 minute. So assigning the senior architects to implement the CD, this is one of the best practice which requires budget allocation. Again, because even if you have written your technical best practices, you invest your budget in bringing the best tools from the market, and you've identified your minimal viable cluster of products also for which you want to implement your DevOps. You've done all of that homework, but now what you've done is you've allocated a junior architect, and just to cut down the cost in the manpower. So that won't work. You need senior architects to develop the MVPs and scale it up with a careful strategy and budget allocation, and empowering as well, because these are some of the things which are being clearly overlooked at times. And the second is apprehension towards automation needs to be identified and addressed through mindset change, sharing the vision, establishing purpose, technical upskilling. Organizations shouldn't hesitate to take difficult decisions also at times. And just to mention, for the digital transformation, I've also written an article. It has been published on my LinkedIn page. You can also go over that article, because any digital transformation anyway would involve automation and DevOps. All right, so the third is prioritizing the continuous delivery and making no compromises in its implementation. Also, I would like to talk a little about the architectural runway. I'm not sure if you've heard about it, but it's a scaled agile framework concept, and it means that there is a existing code, components, and technical infrastructure needed to implement near-term features without excessive redesign and delay. So it is one of the primary tools or frameworks used to implement the agile architecture strategy. So this might be something new, or you might want to read about it, or if you are a safe practitioner, that you would already know about it. Let me now, we've come inching to, so I'm skipping these parts, but definitely we can talk about them later. but definitely I want to talk about the myths in this section really quickly. So many people think, that DevOps is only for startups. No, it is not, because many organizations have gone through transformations to implement DevOps successfully. And to name a few, let me tell you, Etsy, which is it's a retailer, and they implemented the experimentation technique, and they've successfully implemented DevOps in their pipeline. Bank of America is one, Barclays is one, ABN AMRO is one, and there are so many examples. The second myth is that DevOps replaces Agile. Absolutely no. In the entire 1 hour session, we've seen in depth that Agile is a precursor to DevOps. Agile cannot replace DevOps. The third is DevOps means eliminating IT operations. So it absolutely does not mean to eliminate any operation for that matter. Everyone has to do their work in a different manner. That's all. So it does not mean that we have to eliminate IT operations. It just means a more collaborative, cohesive, and automated way of working for effective and efficient product rollout with a cut down delivery timelines. This is what it means. So DevOps only means automation? No, absolutely not. It doesn't. And today, that was my entire endeavor to actually establish this fact that DevOps is a mindset and a cultural shift. It is not only about technology. Even if you bring the most expensive tools from the market, you hire the greatest of technical senior architects in your team, unless you create a culture, you create a mindset shift, DevOps is not going to work in your organization. There will be huge resistance that you will face. And very funny, quality engineering has no role to play in DevOps. And this question is quite close to my heart, coming from the quality engineering background. So that is the reason I wanted to talk about automation at depth, which I did. And quality engineering has a huge role to play. Um, DevOps doesn't need focus bandwidth, which we have established today. So that's all I had in the interest of time. And yes, these are the references which I had promised I will share with you. I recommend these 3 books: The Phoenix Project, Accelerate, and The Team Topologies. So if you have time, I would really recommend that you should dive into these books. They have real good concepts. Okay, so yeah.
Thank you, Divya. With the interest of time, let's take one question. Okay. Giri Kumar asks, is the DevOps limited to software or could it be extended overall project? What I mean is to an automotive product development. We not only have software but hardware, mechanical and manufacturing portion. How this could be explored? Can you quickly explain?
So I am not from the automotive industry, so I don't understand their hardware structures, to be very honest with you. But yes, DevOps is all about maintaining a DevOps pipeline to integrate various stages of production. Now, I think this can be implemented in any industry for that matter. You just have to identify where are you wasting your time doing manual activities. What is it you can do in parallel? How do you bring efficiency to your processes? How do you bring people together, bring them out of the silos? So this is the entire concept of DevOps, and I'm sure it can be implemented in the automotive industry as well. But this is an interesting question. I never thought it that way. After this session, I will definitely dig deeper and see which automotive companies have implemented DevOps. And you can please reach out to me and we can have a discussion. Oh, I'm sorry, I forgot the name. Yeah.
Thanks a lot, Divya. Thanks for an insightful sessions on this particular topic. I can understand it's a really big topic.
Yes,
So
it's a
on behalf of
project. We
the
need sessions actually.
yeah, true. So I think audience has also had enjoyed a lot, and I could see there are a lot of questions popping up. We can see that if you can just offline answer them, and with
Absolutely.
this,
I
yeah,
will be happy to do
and
that
also
without any. the questions to me, I will definitely reach
Yeah,
out to the participants.
sure. And just if you can just type couple of that books in the chat box, that would be helpful for the
Oh,
participant to take it.
yes,
Okay.
I can do that right away. Yes, yes.
Yeah.
Just give me a second. I will.
With this,
Right.
yeah. With this, thank you very much, Divya, on behalf of the community.